Okay, next up on the agenda, we have accepting Goodhart's law in academia on how token rewards can improve upon bibliometrics. This talk will be given by Patrick Joyce, co-founder of ResearchHub. And yeah, pass it off to you, Patrick.
Awesome. Well, yeah, my name's Pat, and I'm here today to talk about the role of Goodhart's law in academia. I'm one of the co-founders of ResearchHub, and to get started, I'm going to share a little bit about my background. I'm a huge science nerd. I was very lucky. In undergrad, I got to study at Johns Hopkins, looking at tumor biology, specifically the epigenetics of cancer stem cells. I fell in love with academic science, decided to start a PhD, went to Boston University to study molecular biology and cell biology, but quickly found that not all labs are quite as wonderful as a well-funded Hopkins lab. There's a lot of issues in the way that we fund and publish academic science that causes a low quality of life for the average researcher and also a low quality of result. So I decided to actually drop out of that PhD program and start medical school at Georgetown, and also found out that clinical medicine is not a whole lot better. So then decided to do something about it and create a project to create token incentives to reward healthy research behaviors. So just to kind of like zero in on sort of the state of academia today, here are 3 solid headlines that I think describe like some really big problems that we're dealing with in the world. There's the replication crisis. Hiro did a great job of highlighting this at the beginning of the summit today. Between 50 to 85% of all science can't be independently replicated. This is a huge problem. There's kind of the advent of paper mills. There's tens of millions of dollars every year being spent on like spam papers that don't serve any purpose except for bolstering one's resume. And then finally, we actually have like a kind of tremendous amount of scientific fraud that exists in the world. If anyone here is familiar with the dilemma around the amyloid beta hypothesis for the pathology of Alzheimer's, it actually was created out of a fraudulent like PhD thesis where someone did Photoshop on a figure in order to birth like a whole field of research where billions of dollars have been spent chasing something that doesn't work due to fraud. One of the results of this, just in the last couple of years, is someone who had risen to the top of science, actually the president of Stanford, was forced to resign because of their role in producing fraudulent research around this hypothesis. So I think this slide does a good job of summing up what we're dealing with today. The Lancet in 2016 estimated that 85% of all research funding is wasted. And when you think about it, it's not really that unreasonable. If 50% of results can't be replicated, that's 50% down the drain right away. And then more than 50% of clinical trials actually aren't fully reported because they don't produce positive results that will reflect well on the publishing academic's career. So when you look at this, back in 2016, this was $170 billion annually that was wasted, or about the GDP of Kuwait. So why does this happen? I think it makes sense to zoom out for a second and kind of look at the economy of science as a whole and how capital flows through the system. So you start with wealthy patrons of science. This can be public entities, nonprofits, or wealthy patrons. What they do is they create requests for proposals where scientists apply for grants. The problem is that it's really difficult to decide who to give your funding to. It's hard to be objective and determine scientific quality. Just as like an example, if you look at the Copernicus and the heliocentric model of the universe, it kind of started out and people thought that it was a really bad theory. He actually, was persecuted pretty significantly. This happens all the time in science. Oftentimes contrarian ideas are kind of like rejected at the beginning, but then over time they're found to be true. So as a funder, it's actually really hard to know who to give your money to. The thing funders use now in order to help determine quality of scientists is something called bibliometrics, or citation-based metrics. The idea here is that you look at a scientist and you judge how productive they are. How often do they publish papers? Also, you look at their impact. When they publish papers, are they cited by other scientists? Here's a very common bibliometric that's used in making grant funding decisions. It's called impact factor. This is basically a measure of the quality of a journal. It's the average number of citations produced by papers within a journal over a 2-year period. So if you publish in Nature, which is a very high impact factor journal, and a funder sees that on your resume, they'll think you're a pretty good scientist. Here's another very common bibliometric called H-index. This is kind of like an average of the number of citations that you generate per publication over your career. If you have a high H-index, you're also very likely to be perceived as a quality scientist by funders. If you look at Google Scholar here, which is kind of like the #1 search engine for scientific research, They have citations front and center on an average researcher's profile. So we have our friend Albert Einstein here. Right at the top of the page, you see the number of citations and the H-index of this scientist. So this is a big deal. And scientists spend a lot of their career thinking about the citations they're generating and how to maximize their own H-index. The problem is that scientists are really smart. When they start to kind of optimize for these citation-based metrics, they prioritize them over producing high-quality science. I'm sure lots of folks here are familiar with Goodhart's law. When a measure becomes a target, it ceases to be a good measure. The use of citation-based metrics is to determine scientific quality. So we're trying to measure quality. But unfortunately, it's become a target for behavior, and so it's not really that good of a measure anymore because scientists are optimizing for citations. So when you're optimizing for citations, what kind of incentives does this create? When you want to maximize your productivity or number of papers that you're publishing, you kind of have to be a little wary of your competition. Rather than sharing with everyone across the world who's working in the same field as you, you kind of guard your data, you guard your hypotheses, you work in closed silos because you want to make sure that you're the one who ends up getting the publication in order to boost your own resume in order to get a grant in the future. When you're trying to maximize impact, you also kind of change your behavior away from just producing high quality research. For instance, if you're studying something, you have a hypothesis, you do an experiment, and you get a negative result, most people don't share those. Because if you get a negative result, it's not that exciting. You're probably not going to get a lot of citations. It reduces your average citations per paper, and it actually makes you less likely to get funding in the future. So negative results just aren't shared. Kind of like at the beginning, I mentioned 50% of clinical trials aren't even shared. Harking is hypothesizing after results are known. So halfway through a project, you might realize that your results aren't that interesting, and you'll kind of pivot the project in order to take advantage of the data that you do have and have a better result. The problem is that this creates low quality science that is hard to replicate and contributes to the replication crisis. And then kind of at the extreme with the amyloid beta hypothesis, some scientists, and actually a frighteningly large amount of scientists, will partake in fraud. Like they'll simply just fake results in order to get more citations in order to move along in their careers. And like you can't even really blame people. When you look at the United States, less than 2% of first-year PhDs end up becoming research professors. So there's this hyper-competitive job market where to even have a chance at having success within academia, you need to optimize your results in order to try and get the best citation-based metrics you can. Because the person next to you probably is, and they're going to get the next grant because they are. So I just want to take a second and look at this quote from Peter Higgs. He's a theoretical physicist who was kind of the namesake of the Higgs boson. So Peter Higgs, he would publish like once every 3 to 5 years, and they would be very like impactful publications that would really like change his field. The problem is that when you publish once every 3 to 5 years, it's not very productive. And so in today's world, he actually doesn't think that he would have been regarded as productive enough in order to receive grants. And this is a problem. So how do we fix it? I think the key, and really at ResearchHub, what we think is the key, is that we need to acknowledge that Goodhart's law is sort of like a law of physics when it comes to academic publishing. Just the activity of trying to measure quality is inherently going to fail. No matter what measure you use, it's eventually going to become a target for behavior, and it's going to be gamed by scientists and lose its efficacy as a measure. So instead, we need to accept that Goodhart's law exists and use it to our advantage, and use these measures as targets for behavior. So this is kind of like a cliche that was in the blockchain industry in 2017, is that blockchain is a hammer looking for a nail. And when you look at the problem of wasted research funding, it's actually an incentive problem. And blockchain and tokenization, token reward structures, are probably the best tools that exist when it comes to actually like creating novel targets for behavior by rewarding people with financial incentives. So you can look at a variety of different blockchain projects, obviously Bitcoin being the most famous, where you can like elicit some pretty weird behaviors out of people. I just checked earlier today, and right now the entire Bitcoin blockchain among all the miners, they're collectively using about the electricity of Poland. So block rewards are able to like incentivize people to spend a tremendous amount of money and energy just hosting instances of this database in order to receive Bitcoin as a reward. So it's pretty effective as a tool in order to create targets for behavior. So at ResearchHub, we're interested, can we take this sort of idea of using token rewards to incentivize specific behaviors and apply it to scientific research? This is just kind of like an overview of our product. Today we have like a Reddit for Science style forum where anyone can share existing publications. They can publish natively to our forum. When you share publications on ResearchHub, they can be upvoted and receive tokens based on what our community perceives as valuable. So we have this ability to sort of create token incentives for specific behaviors on ResearchHub. A couple of weeks ago, our community got together and we were like, hey, let's play around with this. Maybe we can use these tokens in order to incentivize something interesting within the scientific community. So we decided to create token rewards for people sharing open peer review. If you look at this curve here, we've had the ability to peer review on ResearchHub for about 2 years, just as a feature. At the beginning of May, we started to place $150 bounties for peer reviews. So after the first spike, maybe in the last like 6 or 7 data points is when we started to like specifically reward peer reviews with $150 worth of research coin. And as you can see, it's kind of working. We're right now averaging about 140 peer reviews per week using this reward structure. So here's just a little bit more insight on these results. Right now, we're, if you extrapolate it across 12 months, we're going to have 6,000 peer reviews shared on ResearchHub. Normally, a peer review in a traditional scientific journal takes between like 3 to 9 months in order to get like a peer review and get it published. On ResearchHub, it takes about 16 days. So using these token rewards in order to incentivize quick and open peer review is working. And it's actually an improvement on the current infrastructure for peer review. Just like to show this in more detail, if you look at Science, which is probably like the most prestigious journal that exists, they average around 5,000 peer reviews per year. So if we just maintain our current level as of last week, we're kind of at a similar level to Science and some of the biggest journals that exist, which is obviously like pretty cool considering we only started this maybe like 6 weeks to 8 weeks ago. So at ResearchHub, we have this ability to set targets for human behavior using token rewards, which is super exciting. And so what should we try and incentivize? One thing that we're worried about is like as a company, as a group of people, we have about 5 people on our team. Is it possible for just our team to set incentives that will end up like increasing like the quality of research within the world? We don't think so. So we have a DAO, the ResearchHub Foundation. All of our users, people who have been earning tokens, they get together and they actually discuss like, hey, what do we perceive as valuable research and what do we want to incentivize? What do we want to create token rewards in order to create targets for behavior to try and change how scientists operate? So this is what we've aligned on and we voted on as a community. We want to incentivize folks to create open access research. So like any publication, rather than being shared in Nature, where only people with subscriptions are able to read it, we want to reward scientists for sharing open access publications that anyone in the world can read, regardless of where they go to school or what type of subscriptions they have. We want to incentivize pre-registered research. So pre-registrations are kind of like a blueprint for your research. Scientists will share their plan for a research project before they actually do it as kind of like a mechanism to hold them accountable. Rather than maybe pivoting, if you're not that excited about your results midway through a project, you have to stick to what you described in a pre-registration. And that has been shown in an evidence-based fashion to increase the replicability of research projects. And then, of course, we think it's important to have open data. If you share science and you have open data alongside it, it allows anyone in the world to audit your project and then like see if it's actually true what you're describing as the results of your science. So this was voted on by the ResearchHub Foundation, which is our DAO, and we're creating a reward structure in order to implement this. So launching exactly 7 days from now, we have a V2 of ResearchHub's reward structure, where the goal is to reward scientists for sharing open access, pre-registered, open data science. So basically, our plan is to iterate on the current incentive structure in academia. We look at citations and then kind of augment them through the lens of pre-registered, open access, and open data research. So if you published in Nature and you have 1 million citations on one paper, you're going to have a lot of research coin waiting for you. but you're not going to be able to claim it unless you share an open access version of that paper. So it's actually legal for you to share a pre-peer review version of your closed access manuscripts. So if you have, say, like $10,000 worth of research going waiting for you, but it's in a closed access paper, you have to share a pre-peer review version in order to claim that $10,000. These rewards are 3x if it has open data accompanying it, and then 2x again if the project was pre-registered. So our goal here is similar to how we were able to actually increase the number of open peer reviews on ResearchHub to try and incentivize scientists to share open access, open data, and pre-registered science by using token rewards. So we think a lot of the problems that exist in science are due to this poor incentive structure that's a result of Goodhart's law. There are funders who are trying to measure quality rather than trying to set targets for behavior. So at ResearchHub, we're trying to set targets for behavior. And we believe that this is the best way forward in order to incentivize high quality research. So a little bit hyperbole here, but we think if the world decides to accept Goodhart's law and create targets for behavior rather than trying to measure quality, we're going to have a lot more efficient science. So here's some QR codes if you'd like to get involved. And I think we have maybe 2 or 3 minutes. So if anybody has any questions, happy to answer them.
Yeah, thank you, Patrick. So if anybody has any questions, feel free to raise your hand now. I'll come bring you the mic.
Hey, Patrick. Thanks for that. What is the biggest challenge that you're facing in getting those papers onboarded from traditional academia right now?
So it's kind of like a sales issue, which we've started to sort of figure out. So not a lot of people know about ResearchHub, so we have to kind of have our community reach out and tell people we exist. Just in the last maybe month or two, we've started to kind of create an internal inside sales function within our community where we're basically trying to recruit folks to do peer reviews. So we'll have a preprint that's shared, a peer review bounty will be placed on it, and then we'll shoot LinkedIn DMs and cold emails, and we actually get a pretty high kind of conversion rate. It's about 30% of folks that we reach out to will actually come back into ResearchHub and complete a peer review, which is shockingly high for cold outreach if anybody's tried before.
What is the sort of general perception of token rewards? Obviously, the rate is quite high, 30%, but tokens in particular, do people turn their nose up at this?
It depends. So kind of older, successful folks, they oftentimes don't really need the money. And so they're a little bit more hesitant, but we still had some professors and department chairs who were willing to do peer reviews. Younger folks love it. So the ResearchHub Foundation is largely comprised of postdocs and early stage grad students. But yeah, paying people for something they're not currently being paid for is actually pretty successful. So it's, again, kind of just a function of how much outreach we do.
Awesome. Okay, well, that's all the time we have for questions. Can we give one more round of applause for Patrick, please?
Thanks, everybody.
Thank you, Patrick.